Hi everybody, this is Coco Bananas, my best ferret. And she's going to work with us tonight on something that we will use all semester long. We're going to use this idea a lot. And it's called the educated guess. You can see I've got it marked. It's in section 1.8 of your textbook. Hi! All right, so we're going to start with a differential equation. And if you notice, this one is not separable. So it's not quiz-like. It's not something that you'd see on your quiz for Thursday. Eating some of the ferret snack. There you go. Want some snack? Anyway, so it's not going to be on the quiz because it's not separable. But we did one like this in class, and it required integration by parts. So we did integration by parts. And it's an unfortunate thing when integration by parts happens because it's a long process. Well, if we do integration by parts on this, see that t squared times that e to the negative t? That's 2 integration by parts to solve. So that's bad news. I'm just going to stop there because I've got something better for you. So I'm going to erase that because I'm going to need this space later. It's still the same P and Q, but I don't need that anymore. So here's educated guess, and I'm going to give you a handout with everything that we're doing on here. And this will be available on quizzes and tests, final exam. But it becomes a process that you might as well get used to. So first step of the process is the homogeneous equation and solution. And homogeneous equation is genius. Let's take this differential equation right here, the y prime and the y, and set it equal to 0. So just make all the non-y stuff 0, which is nuts. And anyway, so you can see you got dy dt minus y equals 0. And the solution for that is just y equals ae to the t. We did that one in class. You can do it as a separable. Another way to look at it is just look at this. What kind of function minus, its first derivative minus itself is 0? In other words, you need a function that's equal to its derivative. Well, that's the entire family right there. ae to the t. That's the whole family of those. So now comes the educated guess part. All right, the educated guess is, you look at this differential equation right here, okay? How do we get 2 minus t squared? Where does 2 minus t squared come from? It's not going to come from sine and cosine. It's not going to come from e to the t stuff. It's going to come from a polynomial, because what's the derivative of a polynomial? A polynomial. So if you have a derivative of a function minus the function, and it's equal to a polynomial, then it must have come from a polynomial. So check it out. Check this out. Check out how genius this is. We're going to take a guess. So we call it block Y, or uppercase Y, but it's a big block Y. The book uses this notation too. And it's a t squared because we need a t squared to live. There's got to be a t squared in this Y because that t squared comes from somewhere. So you choose a t squared and then everything else on down. And you do the math so that all these numbers are decided, and you make this 2 minus t squared happen. How cool is this? Now watch. That's your educated guess. That's a pretty easy guess. All you need is one derivative of it, because the differential equation has one derivative. So you call it big Y prime, and that's 2b t plus c. Groovy? Just regular old derivative. Come here, you. All right, so now I'm going to do y prime minus big Y. And that's going to be 2bt plus c minus the quantity bt squared plus ct plus d, and that's equal to the 2 minus t squared that we had before. So this is what we get. And now we're going to make b, c, and d happen so that we get 2 minus t squared. Now, do you recognize why I started with bt squared plus ct plus d? It's because I already used a. So I'm just going up and using the alphabet as I go along. That's pretty exciting. All right, now let's check it out. I've got negative bt squared, and that's the only t squared I've got. So if negative b t squared is equal to negative t squared, then b has to equal 1. I already got b already. How great is that? How great is that? That's great. Now, let's take a look at the t's. I have a 2bt minus ct, and that has to be equal to 0 because there's no t's over here. No t to the first. So that means that now b is 1. 2 minus c has to be equal to 0. So c equals 2. Booyah! And the only thing we didn't look at yet was the constant, because there's a 2 over here. There's a c and a minus d. C minus d is equal to 2. But we already have c is 2. So this forces, if I have 2 minus d equals 2, d is 0. So check it out. I'm going to do the hideous eraser method. B was 1. I'm going to write it 1. C was 2. And D was 0. So this is my big Y. And that means this. My solution is always, and when you do educated guess, the solution is always the homogeneous solution plus the particular solution, the big Y. So little y for homogeneous solution, big Y for the particular or educated guess, whatever you want to call it. So the solution is y equals ae to the t plus t squared plus 2t. So if we have an initial condition, we can find that a. And that we solved. We can check. Would you like to check to see if this is actually correct? We have no initial condition, so all I have to do is take the first derivative. Y prime is equal to a e to the t plus 2t plus 2. So let's check to see. If I do y prime, a e to the t plus 2t plus 2, a e to the t plus 2t plus 2 minus y. So I'm just following the differential equation. A e to the t plus t squared plus t. A e to the t plus t squared plus 2t. Sorry, 2t. There we go. Now check it out. A e to the t minus a e to the t is 0. 2t minus 2t is 0. And all that's left is the 2 minus t squared. 2 minus t squared, check. It worked. This is the actual solution right there. You know what was interesting? Did we do an integral? Isn't that cool? And then you do get your arbitrary constant. Remember, when you do a derivative like this, or sorry, solve a differential equation like this, you're supposed to get an arbitrary constant. We have one. So that's the educated guess. I'll be doing another one on the next video. See you in a minute. I just want to save this thing. Stop.